Thank you, dear viewers. Thank you. I am Tutor Cletus Okoli. In today's class, we shall be solving an Olympiad mathematics question as it is written on the board to solve 2 to the power of 3 to the power of 4 to the power of x minus 512 equal to 0. Please watch till the end. It is going to be a brief video, and then if it is your first time of watching my video, kindly subscribe to my channel for more videos. Alright, we dive in right away as it is given to us by solution. I have it to solve 2 to the power of 3 raised to 4 raised to x. The first thing I will do is that I will move 512 to the right hand side, and that will now be equal to 512. Alright, I want us to write 512 in index form, and because the left hand side is written in base 2, therefore we want to express a 512 in base 2, and that implies finding how many times 2 can multiply to give us 512. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, and times 2 is 512. It means that 2 to the power of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is equal to 512. So I can now write my 512 in base 9 and of course in index form. And this is going to be 2 raised to 3 raised to 4 raised to x is equal to 2 raised to 9. Very good. At this point, I want us to make use of this law of indices that says if I have a raised to power x equal to a raised to power y, that when the bases are equal, automatically the powers will not be equal. So x will not be equal to y. When the bases are the same, the powers should be equal. Therefore, applying that here, you can see the bases are equal, base 2 by the left and base 2 by the right hand side. So the power should be equal. And the powers here are 3 raised to 4 raised to x, which will now be equal to 9. That is, I have taken out the bases that are equal. So what I have left is 3 to the power of 4 to the power of x equal to 9. Written down. We continue to move forward. Now that I have 3 to the power of 4 to the power of 9 equal to 9, the base here now currently is 3. So I want to write my 9 in base 3. And 9 in base 3 is the same thing as 9 times 9, which is equal to, 3 times 3, which is equal to 3 to the power 2, 3 raised to power 2. So by the left I have 3 raised to 4 raised to x, and my 9 now can be written as 3 raised to power 2. Very correct. So we do the same thing we did by this law, that when the bases are equal, you can see now that the bases here are equal, 3 as the base by the left hand side and 3 as the base by the right hand side. So automatically the powers now becomes equal, which is the power now is 4 raised to power x, which is equal to 2. Alright, by the left I still have base 4, and because it is base 4, I have to express my 4 to be in the same base as what I have by the right, because the right hand side is actually base 2. So 4 is the same thing as 2 multiplied by 2, which is equal to 2 raised to power 2. Okay? Therefore, I can now write 4 as 2 raised to power 2. And then there is still power x there. Then equal to 2 is the same thing as 2 raised to power 1. Anything raised to power 1 is that. A raised to power 1 is A. P raised to power 1 is P. X raised to power 1 is X. 10 raised to power 1 is 10. Therefore, 2 is the same thing as 2 raised to power 1. Then, I want to bring the power law of indices, where we have that if you will say x raised to power n or to the power of n, by law of indices, the two powers, the exponents will multiply. And that is going to be x raised to power n. So we multiply the two powers. Therefore, I will do the same here by the left hand side. I will use 2 to multiply x. And that will give me 2 raised to power 2x equal to 2 raised to power 1. At this point, we still apply the law of indices that says that when the bases are equal, the powers will now be equal. So my power here, the bases here are 2 to the left and 2 to the right. So they are equal. So the powers now is 2, right this side, 2x is now equal to 1. We are almost at the answer. So we divide both sides by 2. That 2x over 2 is equal to 1 all over 2, giving us x equal to 1 over 2. Final answer. Alright, permit me at this point to check our result. What we want to do next is to take this 1 over 2, which is our final answer for the value of x in the question that we are given. We will take this 1 over 2 and put it inside the question wherever there is x to see if the left hand side will be equal to the right hand side. The right hand side is actually 0 in the question we are given. And by the left we have 2 to the power of 3, to the power 4, to the power x minus 512. After solving the whole of this left hand side, we are expected to get 0, hence x is equal to 1 all over 2. So we check result. Check result. Good. Doing that, anywhere I see x, I am now going to put 1 over 2. So the result we are checking is that we want to substitute 2 raised to power 3 raised to power 4 raised to power x minus 512 is it equal to 0? That is what we want to do. So anywhere I see x, I put my 1 over 2. So I write 2 raised to power 3 raised to power 4, then raised to power 1 over 2. This time around 4 is raised to power 1 over 2. Minus 512. We want to see if it will give us 0. But I want to do this part alone. That is 4 raised to power 1 over 2 is the same thing as the square root of 4, and that is equal to 2. Meaning that 4 raised to power half is equal to 2. So I will now write 2 raised to power 3. Then the whole of 4 raised to power 1 over 2 will now be written as 2. So we have 2 raised to power 3. Then 4 raised to power 1 over 2 will now be equal to 3 raised to power 2 minus 512. We want to see if this will give us 0. Alright. You know, math is life. Math is beautiful. Mathematics is life. Okay, next I want to do this alone. That is 3 raised to power 2. That is what we did before now, and it is equal to 9. 3 to the power 2 is 3 times 3, which is 9. So I now am going to write 3 to the power 2 will now be written as 9. I now have 2 raised to the power 9 minus 512 equal to 0. But remember before now when we started this lesson, we got that 2 raised to the power 9 is 512. When we try to express 512 here, in index form and of course in base 2, we got that 512 is the same thing as 2 raised to the power 9. So the same 2 raised to the power 9 here is bad. We now represent it as 512, then minus 512. You can agree with me now that 512 minus 512 is equal to 0, making the both sides of the equation to be equal. In actual sense, we can now say, therefore, that x in this equation is equal to 1 over 2. Thank you for watching the video till the end. I encourage you to subscribe to my channel so that you'll be getting exciting videos from my channel. God bless you. I remain Tutor Cletus Okoli.